Okay, a subgraph is going to represent key structures inside another graph. So consider the graph that you see on screen now. There's nothing particularly special about this graph. But if I wanted to describe it to somebody, I might look for some special characteristics. So looking at this graph, one thing I might mention is, oh look, there's a square inside. Well, we've learned another name for a square. A square is called a cycle, and you represent it by a C. So this graph has a cycle, C4 in it. It was this B, C, E, and F. And we call that a subgraph. It also has some other special graphs in it. For example, on the left, there's a triangle. A triangle has a couple of possible names. We could call that a cycle C3, meaning that it is 3 points in a ring. Right, a cycle C4 here, I can walk around. But there's also another way that this can be described. The cycle C3, that triangle, could also be called a K3. A K3 means a complete graph on 3 points. In this case, those 3 points make a triangle. It's not a super interesting one, but there are 3 points all connected to each other. Now, I picked this graph so that it has another complete graph in it. It has a complete subgraph, K4. And you might want to think about this one for a minute. And if you do, then you'll have trouble finding it because I left an edge out. There we go. Now it's a K4. So if we look at this, B, C, and D are all connected to each other, and they're also all connected to F. So the complete subgraph K4 here, B, C, D, F. Okay, now it might look like I made a mistake and I was sloppy when I left out that edge here, but actually I did it intentionally, and I'll tell you why. I find that there are a decent number of students on an exam who will say that they found a K4, and actually all they do is put a ring of 4 points. So this cycle, for example, here, some students will say that's a K4 because it's 4 points connected to each other. And so some students would have found a K4 here that actually didn't exist. But without that line through the middle, I could have come up with some other option like A, B, D, F. That is a cycle. A complete subgraph means everything is connected to each other. So that missing edge there that I threw in at the end was essential. Without that, you do not have 4 points that are all connected to each other. Now we have some notation that we use for subgraphs. If I have, say, graph G, and then I have another graph H, let's say I take that complete subgraph, then the way that we say it's a subgraph is that we write H with a less than or equal sign in G. So that less than or equal sign just tells us that H is contained in G. Now I want to make one final comment about subgraphs before wrapping up this topic. A subgraph does not need to include all the edges with those points. So I can take away that edge right there, and this is still a subgraph. H here is missing the edge from B to C, but that's okay. What matters is that everything that was drawn in this figure appeared in G. So my subgraph might include everything, or it might be missing some pieces, and it will still be a subgraph.